Relative positions of a line and a circle. There are three different positions between a line and a circle. First position, line D exterior to a circle. For example, as you see in this figure, we have a circle called C of center O, and we have the line D. It's exterior to the circle, so the line exists outside the circle. And as you see here, there is distance between the line and the circle. And the distance perpendicularly to the line from the center of the circle, for example, here is, for example, 11 centimeter. So there is a distance. The distance between the center of the circle to the line is bigger than the distance between the center of the line and the circle itself. So the radius, bigger than the radius. So OM is bigger than R, which is the radius of the circle. And as you see, we can notice that OM is larger than R. So the line D is exterior to the circle C. The second position is line D cuts the circle into 2 points. This is the circle C of center O, and it's called C, and this is the line D. It cuts the circle within 2 points. For example, there is a distance between the radius and the intersection point of the line and the circle, perpendicularly, of course. So there is the point OM is smaller than R. So the distance between the center of the circle to the intersection point between the radius and the line perpendicularly, which is point M here in this example, is smaller than the radius of the circle, which is OK. And in this case, we can notice, if we have OM is smaller than R, we can notice that the line cuts the circle into 2 points. So the straight line D cuts the circle into 2 points A and B, as you see here in the figure. There is 2 points. So the line D is a secant to the circle C. It's called secant. You have to memorize this word as well. The third position. Line D cuts the circle in 1 point. This is the circle C, and this is the center of the circle C, which is point O. This is the line D. It cuts the circle into only 1 point. So there is the distance between O to the intersection point with the line is equal to the radius. So OM is equal to R, but the intersection point between O and the line must be perpendicular to the line, which is the smallest distance. The smallest distance between the center of the circle to the line is equal the radius of the circle. And in this case, if we have this condition, we can say that D is tangent to the circle at M. So this point is called M, which is the point of tangency, or the contact point between the line and the circle.